Live from New York, it's Ask an Engineer.
Zoom, 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 zoom.
Getting stuff back in stock.
Yes, we're getting stuff back in stock. One of the things we'll maybe we'll talk about later. It's Ask Engineer. Me, Lady Ada, the engineer, and with me, Mr. Lady Ada on camera control. We had a fun-filled, informative 1 hour show for you. We'll be here till 9 o'clock talking about making, hacking, coding, soldering, 3D printing, and more, broadcasting live from downtown Manhattan, where we do all that stuff you just saw, like that time lapse that was shot here in New York, making stuff almost 24/7. But now we have a show. Well, we're going to tell you all about it. So, Mr. Ladyada, why don't you tell them what's on tonight's show?
On tonight's show, the code is glow because things glow.
Oh, double the glow.
10% off data for all the way up to 11:59 p.m. Eastern Time. Use it or lose it. You also get free stuff. We'll talk about that in a minute. We'll talk about some of our live shows, including Show and Tell. We also have Desk of Lady Ada, which includes The Great Search, JP's Product Pick of the Week highlight. We have some advanced manufacturing made in New York City factory footage, 3D printing speed up. We have Ion MPI, brought to you by DigiKey. This week it is ST. We have a really big top secret section.
Ooh, jam-packed. Lunar New Year's over, baby.
Yeah, we've got some new products, and we're going to answer your questions. We do that on Discord, adafruit.it/discord, or discord.gg/Adafruit. All that and more on, you guessed it,
Dun, dun, dun.
Engineer. So let's go over the code and more and the free stuff. What do they get? What do they get? What do they get? What do they get?
We get freebies when you order from the adafruit.com shop. We give you free stuff. We have lots of distributors. Please also buy stuff from them. But when you buy from us, we give you extras. So if you order $99 or more, you get this beautiful black and gold PCB coaster with some bumpers. And if you make multiple orders, now you have a set of 6 coasters. Works out. $149 or more, you get a KB2040. It's our Pro Micro Pinout compatible microcontroller board with an RP2040 chip, which is super hot and popular. And it has 8 megabytes of RAM and a STEMMA QT port and a NeoPixel and buttons and USB Type-C and castellated pads. It's a great starter microcontroller. $199 or more, you get free UPS ground shipping in the continental United States. And last but not least, we have $299 or more, Circuit Playground Express, our favorite all-in-one learning electronics board. No soldering required. You can get started with Arduino or MicroPython or CircuitPython, code.org CS discoveries, make code from beginner to expert. It's got all the LEDs, buttons, sensors, and everything to get started. Like I said, you don't need any soldering. You don't need anything but a USB cable.
Okay, and then let's start off with our AdaBox update. Thank you so much, all of the subscribers.
Wait, is it shipping?
It is.
Where's the person who's always like, where's the inbox shipping? Where are you?
They probably got their AdaBox.
Oh, they're busy. They're opening up.
So we're about halfway through the AdaBox shipments. You can check out. Let me go to. Let's see if I got.
You want to have the report up?
Well, no, I'm not going to do the reporting because that's like internal stuff. But you could go to adabox.com and you can see that we have updates, and we also have the unboxing video.
When is the unboxing?
It's going to be live in 27 days, March 20th at 8 p.m. We have a little YouTube link there. We'll be doing it live across all the channels. So get your AdaBoxes ready and more. Please keep it a secret to the young folks. We'll get through all of them, and then we're going to make sure anyone who just signed up can catch up. We also understand, some people
they move.
Lots change in a couple of years. So thanks for your patience and hanging in there, everybody. But it is happening. If you haven't already, if you are a subscriber, just make sure you log into your account, update your payment and address.
We do have a couple slots too.
We do.
So if you want to, we haven't notified all the people who signed up to be notified when their subscription's available.
Yeah.
But you, the viewer watching right now, get the down low sneak peek. There are a couple spots available. You can sign up right now and you will get this box.
Yeah. And then we should be on track to do the next one, the next one, and the next one. And, we had some choices, what we could do. And we basically said, well, let's keep doing it. And thanks for your patience, everybody. It was I'm glad we do a weekly show because we're able to get the word out and talk about subscriptions, how they work, and then also the chip shortage. We did a segment around it. And if you look at the AdaBoxes that we're coming out with, you'll be able to look back at the part shortage and be like, oh yeah, that was gone for a year. Now they were able to get it. Now they can do, thousands and thousands of AdaBoxes. Yeah. Okay. We do a bunch of live shows. Special thanks to Melissa who just did your show and tell. We were getting our show ready, so we'll be watching that. But don't forget, every Wednesday, 7:30 p.m. is show and tell Eastern Time. We drop the StreamYard link in Discord. You can show maker spaces, retro stuff, books, projects you've worked on, just about anything. All are welcome. On Sundays, we do from the desk of Ladyada. It's in two parts. Ladyada, what did you show off this week?
Okay. This week, I showed off my high voltage UPDI programmer. So a couple weeks ago, we did the standard UPDI programmer, low voltage, and we put that in the shop because that was an easy one. And then the high voltage one is the one that gives you a 12-volt pulse, which means that you can use the UPDI pin as a reset button, which is like for people who use AT-Tinies, it's like a kind of a funky, weird pin. And you can use fuses to configure it, but then you have to use a high voltage pulse. So I talk about that. And then I also talk about a revision I did to the S35710 low power timer chip. I was hoping it could do like deep sleep, like timer capability, but like it turns out it can't. But use watchdog can't capability. So I just talk about the differences between the two things. And then I think I talk about a different micro power timer I found. So yeah, just a couple chips and just showing some revision. Oh, and then the DS4420, I revised it to have a little boost converter because it turns out it's a 5-volt chip, not a 3-volt chip. So a lot of little revisions got worked on this week.
Okay, then we do the great search. That's when Ladyada uses her powers of engineering to find things on digikey.com. What did you look for this week?
Okay, this week, somebody on social media was looking for a 7805 to replace their Sega Master System, or maybe it was a Genesis. I don't remember which one.
That's cool.
But they wanted to repair their Sega, and so they needed a classic TO220 7805. And I'm like, it's such a classic part. We got to cover this. So we found, 1 or 1.5 amp 7805. There's a 2 amp version, although you'll need to heat sink the heck out of it. And then we found a couple other options that are 2 amps that are not discontinued, although they're a little bit more expensive.
Okay. We do that every Sunday, usually around 7 or 8 o'clock, hacker o'clock. On Tuesdays, we do JP's product pick of the week, and here is this week's highlight.
My product pick of the week this week, it is the NeoPixel Featherwing. This is a Featherwing with 32 RGB NeoPixels on it. It plugs right into your Feather or doubler, tripler, quadrupler, and you can control it over pin 6 by default, or cut that jumper and solder up any of the other GPIO pins, which means you can use it on pretty much any Feather. You can see what's this one doing. Hey, this is based on some cool code that Liz wrote, which takes in the PDM microphone. I have a little PDM microphone soldered there to the doubler. Brings in sound, converts it to light. So this is a sort of a meter. I have it just running up from 0 to 32 on the NeoPixels there. You can probably see those colors a little better there with some diffusion there, some diffusion acrylic. Wow, 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 wow. There you go, pretty cool. That right there is my product pick of the week this week. It is the NeoPixel Featherwing.
JP's workshop is on Thursday. That is tomorrow.
Oh, no, not. I think this Thursday is not.
And it's not happening this Thursday, usually Thursdays. And then Friday, deep dive, it's either with Scott or Tim Fummy Guy. You can check that out 2 p.m. Pacific, 5 p.m. Eastern every Friday. Let's do some Python on hardware. We've got some news and reviews and more from the newsletter.
Some good projects in the newsletter this week.
Yeah, so this week we cover a lot. So in addition to Circuit Python 8210 release news, you can check out the notes, news in the industry for those who design Python on hardware. Renaissance bought Altium for $5.9 billion. More consolidation in the industry. So Autodesk has EagleCAD.
Yeah.
And Renaissance has Altium. And KiCad or KiCad, depending on how you pronounce it, is free and open source. Some of our folks at Adafruit use KiCad. We're moving towards it. We have a lot of stuff in it.
Yeah.
Eagle, obviously. We'll see what happens in the industry and what folks use. So is there any other ones that people use that are going to get gobbled up already?
CAD, but I think that isn't owned by anybody.
Yeah.
Is another popular one. Altium is like very popular. A lot of people use Altium.
That's kind of the one, right?
It's like the number one most pirated. And then, yeah, OrCAD is used by some people as well. but I use the Eagle Cat. I still have
And then Eagle Cat is kind of going away.
It is the 2026 is the end date, and I'm slowly, you know, I just wanted to get all these revisions done, and I didn't want to like take
Yeah.
two things, so I wanted to do little revisions. Now that the revisions are done, I'm kind of looking again at Kikan.
Yep. Telegraph interviews Evan Upton about the upcoming stock IPO that is Raspberry Pi going public. Hands-on with the Bus Pirate. Some Python packaging in Rust. Yet another Raspberry Pi 5 review. Helen is interviewed by the Embedded FM podcast. Really good podcast. Check that out. And then all the projects. This was a neat one. This was at Radio Shack. 101. And now
Redoing,
added the
yeah.
Pico. Our popular post of the week last week was the Raspberry Pi alternatives. We also talked about Blinka on the show last week and more. And then we have some custom firmware.
Web
for
workflow got some work today, by
web
the way.
workflow,
Like, today,
yeah.
like hot news, by the way. If you're like, I want to use
press.
WordPress, it's back.
But let's talk about. You wanted to talk about. There was an update.
Yes.
For Memento.
Yeah. So Memento, specifically this board, had a little bit of a bug in CircuitPython 9 beta 1 and earlier that made it so that if you were using the internal file system, the CircuitPy drive, and you dragged really big files, you could accidentally crash the board because it thought that it had a 3 megabyte drive, but it actually doesn't. It has a 1 megabyte drive. And so it gets very confused. Good news, it's not going to damage your hardware. But what you should do is if you have a Memento and you are running, if you've installed something before CircuitPython 9 beta 2, you'll have to erase the file system to kind of reset the board. Or you can install the factory firmware reset over again. If you've never installed CircuitPython before, as long as you install beta 2 or above, you won't get that bug where it accidentally thinks that it's 3 megabytes, but it's not. Again, it doesn't damage your hardware, but you want to make sure you don't crash your board because that's sad. You don't want to crash your board. But thanks to Jepler and Dan and Scott who fixed this super fast.
Okay, great. It's all part of our newsletter. You can go to adafruitdaily.com, sign up for the Python on Hardware newsletter, or you can read it online. You can read on GitHub. You can do an RSS feed. It's all part of Adafruit Daily, completely separate site, so you don't have to worry about getting spammed. We promise, but what are promises anymore? You have
Just
to prove
verify.
it. You have to prove it. Yeah. Let's do some open source hardware news and more. First up, let me go over to the Open Hardware Summit.
There's a summit.
So oshwa.org, you can check out the summit. They announced the speakers and more. It's May 3rd and 4th. It's at Concordia University, and the Less Spacemaker in Montreal.
French.
Spacemaker. Not only can you get the tickets, you can see the schedule, but we're a community sponsor.
Hey.
So some of the folks that we know are going to be there. Check it out. You could also
Let's see some of the presenters. You want to read some of the presenters?
Sure. Go to the presenters. And
this is cool.
Keynote. Yeah, companion robots.
People with green hair.
Yeah. So check it all
Dorman's
out.
there. Oh, great.
Yep.
And Guy, Guy, and then there's a team, and there's a cat. You know, a cool hat.
Yeah.
And then somebody with a neat filter on their image. All right, can't wait to read this. I'm Becky. We know Becky.
That's right.
And
So
Weekly. We also know Lay Weekly. Great.
yeah. So check it out.
This is like a all-star team.
Yes. And one of the cool things is there's a lot of new folks.
Wow, there's a lot of people.
There's a lot of new folks that Open Hardware Summit is a place where you see a really interesting, complete, diverse cast of folks that
You can hang out with them.
that are doing something in the world of open source and specifically open source hardware. There's not really a conference like it, so do check it out.
It's cool. It's edgy, and it's all open.
Yeah. All right, let's go to, speaking of open source hardware, what guides do you want to talk about this week over on Playgrounds? We can also talk about.
We
have some new features.
I think I think we had a couple of projects in Playground, but with the learning system, we only had one guide this week. Last week was like bumper crop. Sometimes it comes in waves. We got the guide for the Neo RGB Stemma new board that we released a week ago. That lets you turn any analog RGB LED strip into a gigantic NeoPixel. So check out that guide. I also made some updates to the AdaBox 21 guide, but it's a secret, so don't open that unless you already got your ADA box. And that's it for
Yeah.
guides. And then playground, I don't know. You want to look at the playground?
Yeah, have you looked at
I-
Playground this week?
I did not look
Secret
in
has some cool
detail.
stuff. And then we also added the little badges, loved by
Oh,
Adafruit.
yeah, we added the badges. Oh, like tie through guide. And then that was from last week. So not as many this week, but I like the Wave Viz. I think C Grover's doing a lot with the Synth.io. So if like you're a Synth.io fan, we should eventually make a way you can subscribe to some authors because that'd be cool to.
Yep, we're adding more features all the time.
Yeah.
All right, let's do some factory footage. And that's what we're making here in New York City. 3D printing. This week we have speed up. We're going to go speed up right to INMPI because we have a lot of top secret this week and we want to try to get out of here on the dot. So we're going to keep moving. Here is this week's speed up from Now Painter. All right, don't forget the code is glow. Let's do some INMPI. INMPI brought to you by DigiKey. This week it is ST Ladyada. What is INMPI of the week this week?
Okay, this week it is the T. Oh, you'll have to click on the link because I.
Yeah, I gotta go.
Yeah, can you click on the?
Yeah.
Okay, the TSC 1641. I want to make sure I get the part number correctly. This is from ST. You can even see the ST logo on the chip. I think this is their first digital power monitoring chip. So they're kind of getting into this new industry. ST's done a lot of sensors and, of course, microcontrollers. But I think this is their first power monitor. And it's definitely their first like MIPI I3C one, I think, which I thought was kind of interesting. So this is a power monitor for up to 60 volts, 16-bit ADC built in for monitoring voltage, power, and current. Very, very small, 3x3 millimeter DFN10. And it has both I2C and I3C interfaces, which is kind of neat. So starting to see I3C make it into some chips. So the traditional way of if you want to measure the current going through a device is in the olden days you would use an analog system like this, where kind of in the middle you see there's a 0.1 ohm resistor, and you use a precision op amp that can go as load rail to rail to the ground rail, and you can add some gain. Looks like about 47 time gain on the voltage across that resistor. And then you can calculate the amperes going through your load, and then you can take the voltage and use a resistor divider on the top to get the voltage from a high voltage down to your analog input. And then you can read it with a microcontroller. Now you've got low side monitoring and voltage monitoring, and then you can calculate the power which is super great and everything, except for two things. One, a lot of components, and you can only do low side easily. It's harder to do high side. You can kind of do it, but you need an op amp that can be that high. Otherwise, it gets like very complicated with the common voltage. And second, you need two analog inputs. Maybe you don't want that. And third, it's not as easy to set up interrupts or have low power because you have to have the op amp and the resistor divider constantly on, which is why this is a cool chip. So this chip has a differential input that is safe up to 60-volt common mode. So you can do either high side or low side measurements. It'll measure both the load and the voltage across a very small resistor that's either placed again at the top or at the bottom of the power rail. And then you can read it 16-bit ADC. There's two of them, one for voltage, one for current. You can read that, do power calculations, set alerts, read the temperature, all sorts of stuff. And it all comes through I2C or I3C with an optional alert pin for easy use. And then there's two address pins. So of course you can have up to 4 of these on one I2C bus, or like I think an infinite number in I3C, which is kind of cool. So the high side is what is, preferable. Like I'll say whenever I do projects like this next one up here, this is an earlier design from a couple years ago. High side's better because you don't have a floating ground, which is one of the issues. If you do low side, then the ground of whatever you're measuring the load of is going to be a little bit higher than your earth ground, which like might be okay, but sometimes can make your circuitry a lot more complicated. Also, you run the risk of accidentally shorting the floating ground to the earth ground, and then like it says that there's no current going through it, and your calculations are all wrong. So high side is the way to go, and it can do up to 60 volts, which is nice because you can handle basically very large battery packs, solar panels, electric vehicles, etc. The current is dependent on the resistor value, and I'll show you in a little bit how to calculate that. But basically, easily can do 10 amps. Okay, so let's skip ahead. Okay, so this is the specifications. The chip itself is powered from about 3.3 volts, but like I said, you can measure up to 60 volts. The total conversion time, can also do averaging and filtering over it. So, you don't want to just measure necessarily like at a point in time. You want to say like over, 10 milliseconds, give me the average current and the average voltage, because if you have a very spiky signal, you don't want to like think that the high point or the low point is representative. So what's really neat is this chip has built-in filtering you can configure. And then the really neat thing about it, compared to other power chips, is that it has I3C support. So what is I3C? It's like I3C is like improved I2C. So like inter chip communication or whatever. This is the improved version. So I3C kind of takes the best of I2C and SPI and combines them. So, with I2C, which is in the middle there, you can have multiple sensors all connected to an I2C bus, but then they all have IRQ pins that are separate. Also, all the peripherals have to have separate addresses. You can't have address collisions, and they're limited. You can't really go above like 1 megahertz. It's rare to see chips that go above 1 megahertz because they have this pull-up system that slows down the communication. When SPI on the very right uses many more pins, and you need a chip select for each one, so you still have like extra pins, and you need extra interrupt pin for each one, but it's much, much higher speed because it doesn't use a pull-up system, it uses a push-pull system, so you can easily get 10 megahertz, like no problem. 20 megahertz, 24 megahertz is very common. So I3C kind of combines the both. You can go from pull-up to push-pull mode, so you can go up to 12 megahertz. Plus, there's no separate IRQ lines required. The IRQs are actually handled by the SDA and SCL pins using what's called like interband signaling, which is kind of handled for you transparently. And also there's dynamic addressing, so you don't have to worry about address collisions, because on boot, the I3C controller can tell each device, hey, generate yourself a dynamic address that doesn't collide with anybody else's, which is quite nice. If you want to have multiple chips with the same address, that is an issue. I will say not every chip supports I3C. It's pretty new. We talked about it like on a INPI like about a year ago. We're starting to see it more often, but it's still kind of new. That said, it is the future. We're going to see more and more devices and chips support I3C. So you can use this as I2C. But if you have an I3C capable chip or microcontroller or microprocessor, you can enter I3C mode by doing this dynamic address assignment. So, it's backwards compatible, but for future use, you know that you have an upgrade path to a faster processor. And this is nice because it's a nice upgrade over the INA series. So like, the INA, I think the 227 is kind of the closest in voltage and precision to the TSC 1641, but the TSC 1641 is less expensive. Competition is great. Thank you, ST, for making better chips that are cheaper. This will make everybody work a little bit harder. And of course, as customers, we benefit. So as I mentioned, you have to calculate and include the shunt resistor. That's the resistor that the current goes through. And there's two things you want to balance. If you have too big of a shunt resistor, you lose precision. But if you have too small of a shunt resistor, you max out how much current you can measure. So you want to get that, because the maximum shunt voltage you can measure is like 8 millivolts, I think. So you want to, maybe it's 32 millivolts. Maybe it's plus or minus 8. Yeah, it's plus or minus 8. So you want to balance between being able to measure the highest amount of current that you're likely to need to measure without maxing out, topping out the internal ADC's range, versus you want to have precision at the lower current. So, if you get below a couple milliamps, you still want to have a couple bits of precision so you can tell the difference between 1 or 5 milliamps. So, you choose it as an engineer. They give you a calculation for guidance, but basically a power shunt resistor about 0.1 ohm is probably a good start. There is also an eval board that looks like it's Arduino Shield compatible, also works with our Nucleo board, so easy to get started. It's I2C, so pretty much every microcontroller board can talk to this chip. And it's in stock
And so,
right now. Yes,
Yeah.
the chip shortage is over.
yeah.
Go get
And
it.
we have a video. We're going to play that, and then we're going to go right into new products.
Does your power supply unit need to be precisely monitored? Do you wish to raise alerts if your battery packs go over or under current, voltage, power, and temperature? The TSC 1641 is our new generation of digital power monitors. It enables safe monitoring thanks to its accurate integrated ADC, its extended voltage range, and its flexible bus interface, the new MIPI I3C bus. Let's jump to our demo of an electrical scale board. Here, we monitor the battery voltage and current under different speeds. We can see the alert when the current goes higher than the limit we have established. So how does it work? The TSC 1641 integrates two 16-bit channels. One is for the current measurement of a shunt resistor with a common mode voltage up to 60 volts, and the other one is for the load measurement up to 60 volts. The power is computed precisely thanks to the fact that they are perfectly synchronized. And die temperature can be measured too. The TSC 1641 uses the new MIPI I3C interface to communicate with the microcontroller and set up the internal registers for configuration, speeds, threshold for the currents, for example. For this demo, we communicate with the new STM32H5. The MIPI I3C interface has a huge advantage in that it can be configured using only 2 pins, clock and data, communicates at 12.5 MHz, and implements upper layer commands known as the common command codes. Concerning your industrial application, where you need to monitor the current, voltage, and power to control the power budget of the entire system, in fact, the TSC 1641 is meant to do that in a precise and secure way. For more information, please visit our website st.com and read our data brief of the TSC 1641. Thank you.
Okie dokie. Don't forget. Logo. That's the code. Let's kick it off with new products.
Okay, so this is back in stock. Finally, it's our dual eyes TFT bonnet, which makes it really easy to add two OLEDs or two TFTs and one some eyeball code on a Raspberry Pi. We are upgrading this code to run on Bookworm, but for now, I think you still have to use a older. If you could use Raspberry Pi Buster, I don't remember the one before Bookworm, but we are working on it. Probably by the time you watch this video, it'll be updated. The revision for this board is it now comes with the 2x20 header on the bottom pre-soldered. You still want to solder on the connectors for the TFT or OLED because depending on which one you are going to use. But just a little revision, get it back in stock. Very exciting.
Next up.
Next up, we also have a revision to our 1.5-inch tricolor e-ink display. So if you want like a little square e-ink with the SSD 1681 driver, you can get red and black on a white background. This has been updated to now have an iSpy connector. So wiring is a lot easier because you can just use an FPC cable and connect it up to like our Cutie Pie or to a breakout board. You can also wire it on a breadboard if you like. But if you want to mount it elsewhere, the iSpy connector makes it easy.
Next up.
Next up, we have this is kind of coming soon, and we'll get a demo and a video for you. This is a 144 LED NeoPixel strip with a nice neon LED covering. So you might have seen like LED neon. We see it usually in a single color. This is full NeoPixel, so you can not only change the color of the neon strip, but you can also change the color of each individual pixel, just like an LED strip. And it's got two connectors on each end, so you can extend them. Otherwise, it's like pretty ruggedized. I don't know if it's, I wouldn't dunk it underwater, but definitely if you're doing like outdoor projects that you want to be able to take outdoors and then maybe not leave outdoors, but you know, for events or to attach to your bicycle or whatever, this NeoPixel neon strip will do nicely.
Okay, and these were kind of stars of the show because
Yeah.
we glow. So what is this? More glow.
We have this is the neutral white version of the double-sided LED strip. So this is a 12-volt single color LED strip, but what's nice is that it has LEDs on both sides. You see, like as this spirals around, there's like LEDs no matter which way you look. So it's great for like a nearly 360-degree glow. Good for illuminating stuff. We have cool white and warm white. This natural white kind of gives like it's not hot, not cool, not red, not blue. It's right in the middle, just right. It's like Goldilocks and the 3 LED strips. And you just give it 9 to 12 volt power. You can also PWM it with a transistor to get nice, beautiful illumination.
It's new this week.
New.
Okay, like I said, we're gonna wrap up a little early tonight. We hope. We got some stuff to do after the show, but that doesn't mean we're not going to do a gigantic top secret section. So you can post some of your questions in Discord if you want. We have a couple stored up, but we're going to start off with top secret first as usual. Okay, the first part of top secret is going to be a video, and then we're going to go through a bunch of boards. 1, 2, 3, 4, 5, 6, 7 new boards.
7 new designs.
All right, lady, what's this?
This is an AT-Tiny 816 board that's programmed over UPDI. It's interesting here is I've got a button, and when I press the button, you'll notice the LED stops blinking because I have the UPDI button set as a reset button, which is kind of nice. You can program or reset the circuit. Normally, the reset doesn't work. What you have to do is actually enable the ability. Hold on, let me find it. UPDI, there you go. Danger, bricks, chips with that high voltage UPDI programmer. So when you set it to be a reset, you can't just send the UPDI signal normally because that could be confused with the reset signal. You have to send it a 12 volt pulse. And so I have a version of my UPDI friend here, which is in the shop. This version has a 12 volt high voltage pulse. So there's a little boost converter and an analog switch. When the RTS pin toggles, it sends a 12 volt pulse to tell the chip, hey, I want to put you in programming mode. So that way you can program it or use it as a reset input. Kind of handy. So now that I know this works, we're going to get this finished up, fix this little blue wire hack, and get it into the shop.
All right, what's this?
Okay, this is the back of. Oh, can you maybe click on that first?
This one?
Yeah, that's the front. Yeah.
Oh, I see.
Okay, yeah. So this is yeah, so there's two, usually there's only one image, but this time there's two. This is like an evolved prototyping pie cowbell. So I want to get back to doing some cowbells. Were doing them in like 2022-ish, and then like kind of I took a break. Getting back to it. So this is the prototype one, but if you look, there's terminal blocks on each end. And so what this means is that you can put like stacking headers on this, and you can plug it into a Raspberry Pi Pico, put the Pico on top and plug into something else. And then you have terminal blocks you can easily wire up sensors or other devices without soldering. So it's like meant for making prototyping a lot easier, and also getting access to pins, even if you have stuff plugged into the Pico W or Pico.
Okay.
Just some revision for the S 35710 timer. Again, I thought it was a low power timer, but it's actually a watchdog timer, which is a different thing, but still kind of useful. So I updated this to add first off, I changed it, the inverter to be an N channel. I also added a little slide switch so you can determine whether you want to have the output inverted or not.
Okay.
Also getting back to some Trinkies. The opposite of a chip shortage is a chip surplus. And I actually have a little bit of a surplus of these SAMD21 E18s. I had like none for like 2 years. It's one of the things that was a little annoying about the part shortages. We were kind of told you have to order 2 years worth of inventory or a year's worth of inventory. And we're like, okay. And then they shipped all year or 2 years worth of inventory at once. So I've kind of got like 2 years worth of these chips, which means I'm going to design a whole bunch of Trinkies. So I thought this would be a fun, easy one. So the SHT45 is a nice precision temperature and humidity sensor. This means this little board, you can plug it into your USB port on your computer or your laptop, and boom, you now have an instant precision temperature humidity sensor. It's going to pipe the data out over the USB serial port in like CSV format, and you can take that data, you can plot it, you can manipulate it with some other program like Python or VS Code or Visual Basic or whatever. So it's got a little NeoPixel and a reset button. So you'll see, and there's a capacitive touch sensor on the end. This is, okay, so I was working on the DS4420, which is a monophonic audio volume, like slash gain chip. And then so I was like, oh, like when was I working on it? And then I realized we did an INPI on the stereo version of like kind of the same chip. So the TPA6130 is a stereo headphone amplifier that can drive 16 ohm loads, which is kind of nice, directly. And you can adjust the gain for 2 differential signals at stereo input over I2C. And I was like, oh, this could be kind of useful. You have audio output, you want to adjust the gain, and you want a headphone amp, bonus. Hopefully it turns on, like when you plug it in, like you don't need to change the gain. It just acts as a headphone amp to start, but we'll find out. It's a little STEMMA QT board to do that. I also have a bunch of extra B&O 055s and BMP 280s, and I thought this would be a good little sensor BFF to go onto a QT Pi or SHA board. Basically gives you 11 DOF. So you get 3 DOF of accelerometer, gyro, magnetometer, and the B&O 055 does the fusion for you, which is kind of nice. So even if you have like a very slow chip or using MicroPython, you'll get quaternion data out. And then the BMP 280 will give you barometric pressure and temperature, so you can do altitude detection. So it's gonna be good for like little drones or robots or like, motion detection. And then this is that revision of the DS4420, the monophonic audio amplifier or audio gain adjuster. Just needed like a new power supply.
And that's a whole bunch of new hardware coming. Ooh.
More too. I'm almost done with this camera cowbell.
Yeah. Okay. Well, for new products, Glow is the code. We're going to go over to Discord. We have some questions lined up. Let's answer them, and then we're going to get you out of here a little earlier.
Yeah. Okay. But we usually go over, so it's like what's in the bank,
Okay.
Withdraw.
So you talked about what is I3C during INMPI, but do you want to have a little brief overview in the question section?
Yeah, so I3C is kind of the backward compatible upgrade to I2C, where you don't have address collisions anymore because addresses are dynamically generated. You can go much faster, 12 megahertz instead of like 400 or maybe 1 megahertz. Probably can also go longer distances because you don't have the pull-up resistors causing big delays on long wires. And interrupts are handled interband, so there's no need for a separate interrupt pin.
This is maybe long overdue.
It is long overdue. I
Seems-
see it's very popular. But it
Seems
does
like
have-
we should have.
And they got rid of clock stretching because they were just like, we're not doing it. So, but you have interband signaling, so you use that instead. But that was very smart. They got rid of it.
Anyone know where I can get some help designing a set of LED poise?
We have a guide on LED poi that we've done. It's a little bit older, but you can
Yeah, someone can post it
you
in the
maybe
chat, maybe.
check the learn guide.
Yeah,
You search for LED poi.
POI.
Mhm.
Okay. Question related to the NPI. Could you include an accurate enough I2C, I3C digitally controlled potentiometer as a shunt resistor in a breakout for the new SEM load monitoring chip, or is that prohibitively expensive? And would it make more sense at that point to try to use an AT Tiny or something as a I3C, I2C overload AK seesaw and some cheaper non I2C digital potentiometer?
There's no digital potentiometer that goes under 1 ohm. They always have like 2 or 3 ohms, so you're not going to be able to use a digital potentiometer even if you wanted to.
Okay. Next up, any good resources on learning about receiving processing radio signals? Thinking about potentially for digital signals beyond using an SDR with Raspberry Pi.
It's tough to beat getting one of those USB SDRs and just like messing around with some of the code available. I think that's kind of like that's the easiest way to get started, especially with receiving. You don't need a license. But of course, if you get a license, then you can do transmission as well.
Okay. How will I3C work with multiplexers? Seems like they might not even be needed anymore.
I think we covered an I3C switch, but no, you would not need a multiplexer because addresses are dynamically generated. So you could have multiple chips of the same like family address, and they would get unique IDs. I don't know how you tell them apart. Maybe they'd have a serial number or something. Maybe that's a requirement.
Okay. And then what's the code? It's easy.
Glow glow.
Close code.
Yeah.
And it is active until 11:59 p.m. tonight. Let me see if there's anything else. I think we may have gone through all
Okay.
the questions.
Like I said, we usually go over.
Yeah, we wanted to get out of here
15 minutes.
15 minutes early this week because we usually go a little bit over, but we
We're
have
gonna have
stuff
some
to do.
more stuff next week. This week was a little bit of it was a short. First off, it was a short week.
Yeah.
Because we had President's Day and second Lunar New Year, kind of delayed a couple stuff. But you're going to see all those.
Yep.
It's not out yet. Don't ask. Come into the shop real soon. You're going to see a
Codes Glow.
plethora.
And don't forget, there's all the free stuff as you go and check out. AdaBox is shipping.
Ship, ship,
Yay.
ship,
Check
yay.
adabox.com. You can still sign up if you want to get it before.
You can sign up and don't forget to update your address.
This has been an Adafruit production. Here's your moment of Zener.
Thanks, everybody. Have a great night.